Welcome to Miss Taylor's class videos, and today we're going to be talking about exponential functions and comparing them to linear functions. So the first thing we're going to do is we're going to use our function f of x equals 2x. Remember, f of x is the same thing as y equals 2x. So I'm just going to simply type in y equals 2x into Desmos, and then I'm going to use Desmos to turn this into a table. So I'm going to hit my settings wheel, and then I'm going to hit table. And so now I can fill in my table of values. So -2 is 4, -1 is negative, oh, that was a -4. -2, 0, 2, 4, and then I can type in 3, and I get 6. Now, if you forget that trick, what you can do is instead of the x, in parentheses, put -2, and Desmos is going to tell you that it's 4, and you can put -1, then 0, then 1, and so you can always replace the x with the number. So now let's graph this. So -2, -4, -2, 0, 0. So if we graph our line, this is what our line looks like. And if I change this back, that matches what we see on Desmos. So real quick, let's see what we notice. The difference between -4 and 2 is we added 2. We added 2. Plus 2, plus 2, plus 2. So we are adding 2 each time. So now let's type in our g of x, which again is just the same thing as y equals 2, and then our x is the exponent. So we're going to hit y equals 2, and then I'm going to hit my A to the B button, and I'm going to type in x. And again, I'm going to turn it into a table and write down my values. So 0.25, which is the same thing as 1/4, 0.5, which is 1/2, 1, 2, 4, and then let me type 3 into the table, and we get 8. So if we look at the Desmos graph, we notice this graph is starting to curve instead of going straight. So I'm going to go ahead and graph -2, and 2.5 is about there, half's there, 1, 2, 4, and then I can graph 8. So I'm going to go ahead and graph this here. And what I know is I know that line is never actually going to cross the x-axis. So if I look real carefully, 1 times 2, or 1 to 2 is +1, 2 to 4 is +2, 4 to 8 is +4. But if I look at multiply, 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So we are multiplying by 2 each time. So we're going to talk about some of the differences that we see. So the first thing is we know that this graph right here is a linear graph. Linear means straight line. And we know it's a straight line because we add or subtract by the same number. And what we also know about linear is that there is no exponent. So if that one's linear, that means that this graph right here is our exponential graph. And so for exponential, I'm going to go ahead and just abbreviate that right here. It's a curved line. And the reason that it's curved is because we are multiplying or dividing by the same number. And because we multiply or divide, the number gets bigger faster or gets smaller faster. And again, the biggest difference is going to be that we have an exponent, which equals our x. So we're going to spend the rest of this notes talking about our exponential function, and this right here is our exponential function. And the thing that tells us that it's an exponential function is our x is an exponent. It's that small little number to the top right. We will also see exponentials written as y equals a times b to the x. Both of these mean the exact same thing. There's nothing different about them. Parentheses tell us to multiply, or sometimes we put the multiplication dot. So again, our exponential equations, we know they're exponential because our variable is an exponent. And real quickly, one easy way to remember this is exponent is essentially where we get the word exponential from. Exponential, exponent. Those two go together. So now we're going to talk about our a value. Our a value is our start, beginning, our initial, and it's our y-intercept. Our b is our rate, our ratio, our percentage, and our b is always what the x is attached to. Rate. Our x is our exponent. And then let's talk a little bit about growth and decay. So our b value gives us an important piece of information. Our b value is going to tell us if our graph is growth or if our graph is decay. So if our graph is growth, our b is going to be greater than 1. So it's going to be 2, 3, 4, 5, 6, 1.3, 1.7, 1.8. If it's growth, it's going to go up as we go to the right, and we call it an increasing graph. If our b is less than 1, then our graph is going to go down as we go to the right, and we call it decay or decreasing. Oh, no, we already have decay in there, so it's decreasing. C-R-E-A-S, decreasing. All right, I'm real quick going to highlight these three things. Go away. Domain, range, and asymptote. So those three things are 90% of the time the same thing. They're not going to change. They're going to be the same for almost every single equation that we look at. So an asymptote is a line, a graph approaches but never crosses. And our asymptote is usually the x-axis, which is a Hoy line. And we know that Hoy is y equals, and the x-axis is y equals 0. For our domain and range, our domain is our x values. Range is our y values. Our domain and our x values go left to right. Our y values go up and down. Our domain is almost always all real numbers. And our range is almost always y is greater than 0. Because the graph, no matter if it's decay or growth, it's never going to cross the x-axis. It's never going to become negative. So now let's look at some of these features. So I'm going to bring out Desmos again. And again, I'm going to just type in the equation that I'm given right here. F of x. You can type in y if you like. It's a little bit faster. 5 parentheses 0.5 to the x. So if we have y equals a times b to the x. We can get a lot of information before we start looking at the graph. But let's first look at the graph just to make sure we understand what's going on. So I turned this into a table by hitting settings. And so -2 is 20, -1 is 10, 0 is 5, 2.5, 1.25, and again, I'm going to have to type in 3, and we get 0.625. So if we start graphing, I can't graph all of these on the graph, but I can graph enough of them. -110 is going to be somewhere up there. 0, 5, 1 is 2.5, 1.25, and then 0.65. So we're going to be going from somewhere up here all the way down, and we're going to get really, really close to that x-axis, but we're never going to cross it. So if we look at our a value, the number that lines up with it, or the number that is not next to the x, is our 5. Our y-intercept and our a are the same thing. So our y-intercept is also 5. Our b is always going to be the number next to the x. So it's 0.5, which tells me that our graph is going to be decay because b is less than 1. And again, we said our domain, our range, and our asymptote are almost always going to be the same. All real numbers. Y is greater than 0, and the line that the graph will never cross is y equals 0, which is our x-axis. All right, so we're going to do the same thing with this one right here. So I'm going to type in my equation. I'm going to use y equals this time, parentheses 3 to the x. Settings table, 0.111, which I happen to know is 1/9. 0.33, which I know is 1/3. 1, 3, 9, and I'm going to type in 3, which is 27. So again, we go to graph this. 1/9 is going to be there. 1/3. 1, 3, 9 should be about right there. So I've got enough information that I can go ahead and keep graphing. So again, go ahead and write down y equals a times b to the x. So it's really easy for us to figure out our b. Our b is always the number next to the exponent. It's 3. It's going to be a growth graph because our b is greater than 1. But if we notice, there are no other numbers in the equation. But we know anytime there's something, a parentheses or a letter, we always have our invisible 1 in front. And so our a value is that invisible 1, which is the same thing as our y-intercept. And if we go and we look at our graph, yep, our y-intercept is 1. And if we look at our table, our y-intercept is 1. Again, domain and range. Domain is all real numbers. Range is y is greater than 0, and asymptote is y equals 0. Again, our asymptote on this graph is the x-axis. All right, I want you to do these two on your own and check them with the completed class notes.